Yeah, because the first page is just kind of a review. All right, so can you pull anything out? Do you have, these are the questions you want to ask yourself. If you can, use it and make it easier for you to factor. Number 2, do you have 2 terms? 2 terms might imply the difference of perfect squares. Really, really important concept to learn, difference of perfect squares. Use the AC method? No, we're going to go back and we're going to say box method. We're going to do the box method. Okay, because that'll help you factor every single time. Okay? All right. Am I solving in these first few problems? Why not? It's not equal to 0, and I'm not asking you to solve, or I'm not asking you to find the zeros. I'm simply asking you to factor. On a quiz or a test, I might set this equal to 0 in the problem, and I might only tell you to factor. So you really need to read my instructions, because you have to understand the difference between factoring and finding the zeros. Does that make sense? Michelle? Yep. For these first 2 lessons of factoring, and after that, I don't care. All right. All right. Can we pull anything out? We can pull out a 3. So if I pull out a 3, I'm left with s squared minus 8. Is this the difference of perfect squares? It's the difference, yes. But is 8 a perfect square? No. So, but if it was a 16, yes, it would work. Oh, okay, sure. So sometimes the most you can do about factoring is to pull a common term out. And that's all I can do. It's still considered factored. Okay? All right. I like my first term to always be positive, my squared term to be positive. So one of the questions when you say, can I pull anything out, is maybe I need to pull out a negative value. Okay? So I have negative 16n squared plus 12n. What can I pull out that would make this life a lot easier? Alex? Negative 4n. Right, 2 terms. Not the difference of perfect square. Pulling out both a negative and a variable, because they're in both of those terms, makes it easier. That now changes this to 4n and a minus 3. So careful about it. If you're pulling out that negative, you've got to do a sign change inside your parentheses. Okay. Can I pull anything out? 2. That leaves me with 4t squared plus minus. All right, so we don't have the difference of perfect squares. We can't pull anything further out. This is where the box method really comes in handy. So we use our box, and we say we're putting 4t squared here and negative 5 here. And so I want, yeah, it does. You do 4 times 5 in here. What's the product of 4 times 5? Negative 20. And what do we want to get still? 19. See, before, in the previous lesson, our coefficient was always 1. Okay, which is why we just always use the last term. All right, so what are my factors of negative 20 that give me 19? 20 and negative 1. So 20t, negative 1t. Pulling up, what do I pull out? Positive 5. It's whatever the term of these top spots are, or the sign. What about 4t squared and negative 1t squared, or t? T. Pulling across, 4t squared and 20t gives me a 4t, and here gives me a negative 1. T plus 5 and 4t minus 1, and you're done. It's a lot faster than the trial and error. This is when the box method really, really comes in handy. Rachel? Yes. You want to make sure, thanks, that because you pulled that 2 out, we want to bring it down because I've just asked you to factor. Michelle? Because it's really the product of 4, it's the product of the first and the last term. Yesterday when we did it, our first term had a coefficient of 1, so we just always looked at the last one. Okay. Did that answer your question, Grace? Did it answer? Okay, yeah.
I understand the problem, but like, how is the box method quicker than just like, because you don't know if it's 4.
Well, because what are your factors of 4? You've got 2 and 2, or 4 and 1, and your factors. So it eliminates that. Let's try 2 and 2. I mean, for some people, it becomes it's very tedious. They don't see that automatic combination of how to get the middle term.
No, like I have to look at it, but I don't understand why we could try 2t. Like if I tried that,
You could.
it would just be like guess and check.
Yes.
Box.
Right, and it's a waste of time. Whereas the box method gives you an answer immediately, because you can figure out what your products of negative 20, they give you 19, you know what the combination is, you set it into your box and you factor it and you haven't lost any time. They're not all going to...
Try 2t and you have wasted time.
But if you instead of just putting them into the box, you can just put it into the straight into the parentheses for your head.
But you're not having to try the box. This is giving you immediately what it is going to be. Let's try next one. All right. Can I pull anything out? Okay. So that gives me 3x squared minus 7x minus 6. So 3x squared negative 6. I'm looking for my product of what? Negative 18, that gives me? What are my products of negative 18 that give me negative 7? Negative 9x, 2x. Pulling up, we can pull up, what can we take out? Negative 3 here, and up here, and across, and across. So x minus 3, and 3x plus 2 with the 4 that we pulled out, and we're done. What, Catherine? Okay. What about this next one? What can I pull out? Leaves me with 2z squared plus 11z plus 12. And so using my box, I put 2z squared and what? 12. I put 12 here. All right, and then here, what goes here? What am I looking for? The product of what? That gives me? Okay. See how you right away find that combination? So we're going to do 3z, 8z. Does it matter where the 3z and the 8z go? No, they're interchangeable. You'll get the same answer no matter what. So I can pull out a 3, I can pull out a 2z, I can pull out a z, and I can pull out a. So therefore 2z plus 3 and z plus 4 with the 3 that I factored out, and I'm done. Are we good? You like this? You like this so much better than geometry.
It makes me happy.
Oh, okay. All right. So let's go to the next step. All right. So solve. We're going to go to the solving part. Okay. Solve the following equations. These other examples that I'm skipping, if you want to go back on your own, the answers are on the notes page. All right. So we're still going to pull out what we can. Can I pull anything out of the first one? And that leaves me with 2x squared minus x minus 21 equals 0. Does this 3 disappear? Sure can, because it said equal to 0. I absolutely can divide everything by 3. I don't divide by a variable, because a variable gives me an answer. But a coefficient, a number, if it's set equal to 0, just divides out. So really what I need to do is solve the problem 2x squared minus x minus 21. So 2x squared, negative 21, product of negative 42 that gives me negative 1 would be 6 and negative 7. And so I can pull out a 3. So depending on what you put in what box, I'm going to pull out a 3, an x, a 2x, and a negative 7. I'm going to get x plus 3 and 2x minus 7 equals 0. Is this any different than what we did yesterday? X will equal negative 3 and 7 halves. Are we good? Use the box method tonight. Have a good day. Lunch?